Function notation, section 1.1. The height of a rocket at time t seconds after fuel runs out, h equal negative 16t squared plus 32t plus 48. And h is a function of time. Height is a function of time because there's only one formula for h. And in order to emphasize height is a function of time, sometimes we write this as h parentheses t. In this context, h parentheses t does not mean h times t, but it just emphasizes that h is a function of t, or height is a function of time. And we read this as h of t. So h of t is equal to negative 16t squared plus 32t plus 48. Okay, so we can use this formula to evaluate height after different periods of time. So the height at time -1, h of -1, replace t in the formula with -1, so we'll have negative 16 times -1 squared plus 32 times -1 plus 48. -1 squared is 1, 1 times negative 16 is negative 16, 32 times -1 is negative 32, copy the plus 48, and we get negative 16 minus 32, which is negative 48, plus 48 is 0. In the same way, we can do the other ones, height at other times in the same manner. Height at time 0, negative 16 times 0 squared plus 32 times 0 plus 48 is 48 feet. Height at time 1 second after the fuel runs out, negative 16 times 1 squared plus 32 times 1 plus 48 comes out to be 64 feet. Height at time 2 seconds after fuel runs out, negative 16 times 2 squared plus 32 times 2 plus 48 comes out to be 48 feet. Height at 3 seconds after fuel runs out, negative 16 times 3 squared plus 32 times 3 plus 48 comes out to be 0 feet. Okay, so we can use those values of h to make a graph. These are the values that we computed. We have -1, 0, 0, 48, 164, 2, 48, 3, 0 to sketch the graph of the height of the rocket. Now, the formula really only makes sense from time 0 to time 3. So this is a piece of a parabola, but for the times less than time 0, I put that in with a dotted line, and for the time after 3 seconds, I put that in with the dotted line before. Before the fuel runs out, there's actually a different equation that would apply because when the rocket's burning fuel, it's actually sort of increasing its speed. But once the fuel runs out, gravity is slowing it down. So it's going to be a different formula before time 0. Also, the ground offers much more resistance than air does. So once it hits the ground, it's going to stay on the ground. It's not going to keep on going down. So the part of where the formula actually applies, the piece of the parabola where it actually makes sense, is from time 0 to time 3. So that will be our domain. Our domain will be a time 0 to time 3 seconds, and our range, the highest height is 64 and the lowest height is 0. So our range would be from 0 to 64 feet. Okay, so the domain can be expressed in set builder notation, set of t such as 0 less than or equal to t less than or equal to 3. In interval notation, it's 0, 3 with square brackets. The square brackets indicate that 0 and 3 are included. The two endpoints are included. The set builder notation for the range, set of h, set that 0 less than or equal to h less than or equal to 64. In interval notation, it would be 0, 64 with square brackets, again indicating that the two endpoints are included. Okay, so here's another example. We have a formula y equal x squared minus 6x plus 5. Now, here I like to include some practical examples, but this is more like a generic example, and I like to include both because some of the problems in the text that you'll encounter are sort of generic example with no particular application. So we have y equal x squared minus 6x plus 5. For generic functions, usually the letter f is used to represent a function. So we can write this as f parentheses x. And again, this does not mean f times x, but it means that it's just emphasizing that f is the function of x. And we reread it f of x. So f of x is equal to x squared minus 6x plus 5. And we know it's going to be a function because we only have one formula for y here. Okay, so f of 0, replace x by 0, we'll have 0 squared minus 6 times 0 plus 5, which is 5. We can also put algebraic expressions for inputs. Up to this point we've used numerical inputs, but we can also use algebraic expressions. So f of x plus h, and the formula for f of x, wherever you see an x, you put an x plus h. So instead of x squared, we'll have x plus h quantity squared. Instead of negative 6 times x, we'll have negative 6 times the quantity x plus h. And we'll copy the plus 5. So we can expand this with, write the x plus h quantity squared as x plus h times the quantity x plus h. Also distribute the negative 6 times x, negative 6 times h. Copy the plus 5. We can expand this with the FOIL method. First times first, x times x is x squared. The outer product is x times h. The inner product is h times x. Combine those, we get 2 times h times x. Last times last, h times h is h squared. And that's about as far as we can take that. Okay, there's a formula that comes up in calculus. It's called the difference quotient. And the formula is f of x plus h minus f of x all over h. And we've already computed f of x plus h. So that's right here. And minus f of x is just going to be the same function f of x, but with opposite sign. So instead of x squared, we'll have negative x squared. Instead of minus 6x, we'll have plus 6x. Instead of plus 5, we'll have minus 5. And there's 3 of these terms will cancel with 3 of the f of x terms will cancel with the f of x plus h term. So altogether 6 terms will cancel. We're left with, so the x squared will cancel with minus x squared, minus 6x will cancel with 6x, and 5 plus 5 will cancel with minus 5. So we're left with just 3 terms, 2hx plus h squared minus 6h all over h. So now we can distribute the denominator, and the 2hx over h, the h's will cancel, the first term the h's will cancel, and they'll just give us 2x. The second term, h squared divided by h is h. The third term, the h's will cancel. Minus 6h over h will just give us negative 6. So this simplifies to 2x plus h minus 6. Just to say a little bit more about this formula. Again, it's called the difference quotient, and it represents the slope of the secant line. The secant line touches the curve, touches the graph in 2 points. And the 2 points will be when the 2 points are x comma f of x plus h, and the other one is x plus h comma f of x plus h. So so it touches the graph in 2 points, and it represents the average rate of change. This doesn't look very much like a slope function, but recall that the usual form of slope, we have the difference of the y values over the difference of the x values. So the y value, f of x plus h and f of x represent y values. And the difference of the x values, well, the x values are x and x plus h, so if we subtract those, we get h. So this does, on first look, it doesn't look much like a slope formula, but if you look at it more carefully, it actually is a formula for the slope between these 2 points here, between x, f of x, and x plus h, f of x plus h. In calculus, we like to take, once we've simplified that and canceled the h in the denominator, we like to replace h by 0, and that actually gives the slope of the tangent line. The tangent line hits the graph at only 1 point and represents the instantaneous rate of change. So in this formula here, this expression here, if we replace h by 0, will give us 2x minus 6, which is the formula for that gives us the slope of the of the curve at each point of the graph. So the graph is going to be a parabola. The slope is not going to be constant. It's going to change from one point to another. But this is the formula for the slope that gives the slope at each point of the graph. And that concludes this presentation.